Hello everyone, my name is Muhammad Atallah Alimusa. My student ID is 103012440001. So today I will be explaining about my assignment answer for the CLT and CL3 and CL4. So this is about the real world application about the material that have we learned in CLO3 and 4. So in the first question, due to a storm, air traffic control instruct a pilot flying at an altitude of 4 miles to make a 90-degree horizontal turn while climbing to 4.2 miles. The path of the plane during the maneuver is modeled by this equation. So the first question, find the speed of plane during the maneuver. So we already got the path, or we can call it also the position. So to get the velocity or the speed, we need to derivative the we need to derive the position here and do the magnitude. So 10 cos 10 pi t will become, if we derive it, will become minus 100 pi sine 10 pt squared, etc. And then we can move 100p squared to the outside because both of fraction have it, and this will become 1. It's if we have sine to x plus cos square x, it means it will become 1. So what we left is square root of 10,000 pi square plus 0.04. If we use calculator, this will approximately become 314.2626 miles per hour. And then for the second one, compute the tangential and normal component of acceleration, or AT and A in. Which one is 0 and why? So first we find AT. We can find it with the derivative of the magnitude of the velocity, and we have already counted it in the first question. So we know that there is no t left here, and we can conclude that it is a constant, and if we derive the constant, it will be 0. So the 1 is the AT, or tangential, because it's a constant. And the next one is AN. We can search it by this formula, and the final answer is 1000 times p square. For the second question, is still from CL3. A car travels along the curve y equal to 1 over 3x to the power of 3, where both x and y are measured in mile. The maximum safe speed on the curved path is inversely proportional to the square root of the curvature at that point. The first question, if a car can safely travel at 3 miles per hour at the point 1, 1 over 3, how fast can it safely travel at point 3 over 2, 9 over 8? So first we find the curvature using this formula. The absolute value of second derivative fx over the over 1 plus the first derivative of x squared, and we to the 3 over 2. So we know that fx is 1 over 3x to the 3. So the fx will be x squared, and the second derivative will be 2x. So we compute it to the formula and we got this formula now. So first we found at converter at 1, it become square root of 2 over 2, and when the x is 3 over 2, it will become 192 over 97 to the 3 over 2. So we use the inverse square root proportionally, and we got the final answer is 56.3 mile per hour. So interpret the geometric significance of the curvature in terms of rope safety. So the higher curvature means the tiger turn, which require slower speed to maintain control and safety. Lower curvature allow faster travel. So we got here 56.3 mile per hour. That means at this point at 3 over 2 comma 9 over 8, the curvature will be more tight than the curvature in the point of 1 comma 1 over 3. So next one is we move to CLO4. This is number 3. When the temperature in Celsius at point x comma y on a metal plate is given by this function. So first is compute the gradient of vector t and interpret its direction in the context of heat flow. So we know if we want to find the gradient, we need to compute fx and fy, which is dou t over dou x and dou t over dou y. So we got 400 times e to the minus x over 2 plus y over 2 times minus x for the fx, and for fy it's the same thing. Beside the minus x, in here it's minus half. So this is for the I and this is for j. So interpret its direction in the context of its flow. The gradient vector points. So the gradient vector points in the direction of maximum increase in temperature. In heat flow, heats move opposites to the gradient. And second one, find the unit direction vector from 3,5 in which the temperature remains constant. So we need to find unit direction when it remains constant. That means it will be equal, the dot product will be equal to 0. So first we already got the gradient vector. We just substitute the x and y with 3 and 5. And we got this equation. And then we dot product it with a vector v. I use a, b as a variable here. And this should be equal to 0. And because the E is not because the E does not do anything to the gradient, so I remove it and we left with A times minus 1200 plus B times minus 200 is equal to 0. And we got in the final answer minus EA is equal to B. That means any vector in the form of A, comma, because B, we find that it is minus 6A. So all vector in the form of A, comma, minus 6A will work or will remain constant. And last but not least, this is last question, number 4, still in the CL04. So a candle manufacturing company produces candles at two locations at cost function in dollars for producing X1 units at location 1 and X1 units, I mean X2 units at location 2 are given by this equation. Each candle sells for $15. The total profit is in this question. So first find the value of x1 and x2 that minimize the profit. So first we need to substitute this formula into the profit formula. And we got this equation. And then to get the critical point or the maximum value, we need to derive it and equal to 0. So first we derive to the x1, we got 275, and second one we derive it to the x respect to the x2, and we got 110. So for the second question, interpret your result in terms how many units each location should produce. We already got the answer here. So the x1 or the units at location 1, they should produce 275 units. And for the x2 at location 2, they need to produce 110 units. So that's all for this video. Thank you for watching.